Hey guys, on this worksheet we're going to be looking into savings accounts and different types of interest. We're going to be looking at simple interest in this one mostly, but we'll be looking at some other things too. So starting from the beginning, a savings account is an account in which the bank pays interest for the use of the money deposited in the account. So you deposit money into the account, so much money, and then they give you back a percentage of that money added onto that. So the money on deposit with a bank is actually used by the bank to give loans, so that's where they get the money to give the loans to other people from. And then the people who borrow the money from the bank have to pay it back with their own interest, so they don't just have to pay how much they borrowed, they have to pay more. The interest that they pay is actually greater than the interest the bank pays the people who put the money into the savings accounts. So the bank is still able to make a profit. So interest is based on two things. So it's going to be based on the interest rate and the principal, or the balance of the account. So the interest rate is the proportion of the balance that will be paid by the bank. So what percentage of the amount that you have in your account is the bank going to give you back? So the annual percentage rate, or APR, heard that before I'm sure, is the yearly interest rate. So every year it's this much money is paid by the bank, this percentage. There are two classifications for interest. So like I said, there are simple interest and compound interest. We're going to be looking at simple interest this time. It's going to be much more, again, simple than compound interest. But simple interest is just interest that's based only on the original principal. So I have a formula written down here. This is the simple interest formula. It's I equals PRT. I is the interest. P is the principal or the balance. Okay. R is the annual interest rate, and it's represented as a decimal. You always have to have it as a decimal, not a percentage, when you're doing these calculations. And then T is the number of years. So if you're looking for, since T is the number of years, if it gives you months, so if it gives you any X months, so like it's 6 or something, you'll put that number divided by 12. So for example, if it were 3 months, you would say T is 3 over 12. If it were 2 months, you would just say that T is 2 over 12, because it's 2 out of the 12 months of the year. And since this is written in years, it has to be written in years, in order for the formula to work. So a lot of people ask, is there actually any risk in putting money into a savings account, since these banks do actually use that money to give people loans? Well, the Federal Deposit Insurance Corporation, or the FDIC, actually guarantees that it is safe. So they basically insure each depositor. So the person who is depositing the money into the savings account, they have a type of insurance on this savings account up to a specified amount. I think it was in 2017, it was $250,000. So, but it changes each year. And then if something happens and the bank fails, you're not going to lose your money, and the money is paid for by the federal government and you get your money back. So banks actually offer many forms of savings accounts. The most common type of savings account you're going to hear about is going to be a statement account. Let's see if I can write statement account. Okay. Where you receive a monthly statement, and it's going to show you all the activity, including the deposits, withdrawals, interest earned, and any fees that the bank charges. Some savings accounts require a minimum balance as well. So with certain accounts, a fee is charged for each month that the balance falls below the minimum amount. Some banks don't pay interest if a savings account falls below the minimum balance, so you have to have a certain amount at least in that bank account, or they won't give you interest, or you're charged every month. Another popular type of account that people like to use is a money market account. Okay, so it actually has a higher interest rate, but it usually requires a greater initial deposit, so you have to give them more money at the beginning to put in the account, and it has a greater minimum balance requirement, so you have to keep so much money in the account. But with these things, it does have a higher interest rate, so you'll get more money with it. You may be limited to a certain number of transactions per month in one of these accounts as well, so that you're not using it as though it's a checking account as opposed to a savings account. A certificate of deposit, or a CD, is a certificate that states that you have a specific sum on deposit, so you've put this much money into the savings account, and it guarantees the payment of a fixed interest rate. So you're guaranteed this fixed interest rate until it reaches maturity, which is just a specified date in the future. Maturity dates can be from 7 days to 10 years. So whenever you use a certificate of deposit, you say, okay, you have this certificate, and it says you deposited so much money, and up until for the next 2 years, you will get so much interest added onto that. Usually the longer the term is, the higher the interest rate. So if you're going to wait 5 years to use the money, they'll give you a higher interest rate based on your amount, as opposed to if you would just wait a week to use the money, for example. You can't actually make deposits or withdrawals from a CD without a penalty, so you're supposed to leave the money in there until it reached maturity, until you've hit that certain date that the bank has specified. And if you do have to deposit or withdraw money from it, then chances are you're going to have to pay a fee. Arithmetic sequences, okay? So it's a common practice for people to collect coins at the end of the day and put them in a jar at home. You know, most of us use the big Coke bottles or something. For example, if Joe buys a cup of coffee each morning for $1.50 and he pays with 2 $1 bills, he could put 50 cents in coins in his jar at home at the end of every day. So actually determining how much money he would have on so many days later can be modeled by using an arithmetic sequence. Okay? So in an arithmetic sequence, the difference between any two consecutive numbers, so a sequence is just a bunch of numbers in order, okay? So the difference between any two of the numbers that come right after each other is going to be a constant number. So each day, for example, in this example, he's going to deposit 50 cents more every day. So every day, like the amount of money in his jar will be 50 cents more each day. So if he's got like $15 in it at the beginning, and then the next day he's got $15.50, the next day he's got $16, each day, each one in order is going to be exactly 50 cents apart from each other, so the number is going to be constant. The constant that represents the difference between the consecutive terms is considered to be the common difference. So subscripts, just the tiny letters at the bottom of the line, are used to indicate where in the sequence a term is. So, for example, if you're just listing off terms, the first term is going to be A sub 1, so you literally just have an A with a little subscript 1. If you have the second one, it will be A sub 2. Third one's A sub 3, like that. So the nth term, whatever number you're looking for, the nth term, so that would be like the third or the fourth term, is going to be denoted as A sub whatever term you're on. So like I said, if you're on the second term, it's A sub 2. If you're on the third term, it's A sub 3. Fourth term, it's A sub 4, and so on. Okay? The common difference is denoted as D. An arithmetic sequence can be finite, which just means it ends at some point, or it can be infinite, which means it continues going on forever. It doesn't end. I have an example. It says 2 examples. There's only one example on here of an arithmetic sequence. One of them, or the one that you see, it ends with a period because it's finite to show that it ends. And then if it were infinite, it would end with an ellipsis or just the 3 dots at the end to show that it continues on. So this example is a finite one. We have 7, 11, 15, 19, 23, and all the way up to 63. So our example here, if we wanted to label them, we see that 7 is the first term, so it's A1. A2 is 11. A3 is 15. A4 is 19. A5 is 23, and so on. Okay? So in algebraic terms here, we have that the second term here is going to be equal to the first term plus the difference. The third term is going to be equal to the second term plus 2 times the difference. Fourth term is going to be the third term plus 3 times the difference. Okay? So if you looked at these subscripts of the term that you're wanting to compute, so here we're looking at 2, and then you look carefully at the coefficient of d, so the number that's being multiplied by d, you can compare the two. So here we have 2 and 1. Here we have 3 and 2. 4 and 3. You can see that it's 1 more. So the subscript is going to be 1 more than this coefficient. So for each one, we're going to take a sub n to find whatever number we're looking for down here. It's going to be a1 plus 1, or n minus 1, so whatever one you're trying to look for, minus 1 times d, which will be a little easier to understand once we go through an example. So this expression makes sense because in order to arrive at the nth term, whatever number term you're looking at, the common difference has to be added to the first term n minus 1 times. And that's where the first term plus n minus 1 times in order to get to the nth term. So let's look at example 1. Lisa has a glass jar in her office that she's going to use to collect some coins. She starts it by putting in 11.25. She already has, all right? She pays for a commute to work each day and receives 70 cents in change. Each day she's going to add that 70 cents into the jar. Okay? Well, after 100 work days, she's going to take all the change and deposit it into the bank. So how much will she have after 100 work days? So started out with 11.25. Okay? So this A1 is whatever you start out with. So we have 11.25. So A1 is always going to be whatever you start out with in the problem. Okay? N is going to be the number of days or whatever you're looking at. So we're looking at after 100 days. Okay? And then the difference, the D, is going to be how much she's adding each day. So she's adding 70 cents each day. If she were taking it out of the jar, you could make it negative, but since she's not, we're going to keep it positive. And so we're going to start out by stating the formula. So above we wrote that A sub n is going to be equal to A1 plus n minus 1 times d. Okay, so now we're going to substitute in our values. So we're looking for A sub n is 100. We have A1 is 11.25 plus n again is 100. We have this minus 1 still, and we're multiplying it by this value for the difference, which is 0.70. Okay? And now we're just going to solve because we're trying to find whatever this A100 is, whatever the 100th term in the sequence is. We type all of this in a calculator, 11.25 plus 99 times 0.70, and you're going to get $80.55. So, after 100 work days, she'll have put $80.55 in coins into her jar. So again, go ahead and start with the formula and writing out your variable values over here that you got. Substitute those values in. So n was 100, so we replaced that there. Here's A1, we replaced it with 11.25. N, once again, we replaced with 100. And D, we replaced with 0.70. Then you're just going to solve. So we'll do a quick little understanding check. An arithmetic sequence has first term, so A1 is 25, and a common difference of 3. Okay? It says to find the 50th term. So n is going to be 50. That's what we're looking for. So again, we're going to write the formula first. Okay? And so A sub n is going to be a sub 1 plus n minus 1 times d. Okay? Now we're going to substitute, because we know what a sub n, or we know what n is, we know what 1 is, a sub 1, and we know what d is. So we keep a, we have sub n is 50, so we'll change the n to 50. A sub 1 is 25. N, again, is 50. We have this minus 1, and then we're multiplying it by d, which is 3. If you type this side over here into a calculator, you'll get that A50 after you solve is going to be 172. So that's all you're going to do. Figure out which variables or which values. Go ahead and write out the formula, substitute those values into the formula, and then solve. So another understanding check. So this one, it tells us we're trying to find the difference. Okay, so we know that a sub 1 is going to be the first one, so we can say that a sub 1 is 211. And then we can look at any of these other ones and use it. So this is going to be a sub 1. This one's going to be a sub 2. So we can just go ahead and say that a sub 2 is 223. And if we're using a sub 2, n has to be 2. So again, if we write the formula, we have a sub n is equal to a sub 1 plus n minus 1 times this difference. So a sub n is going to be a sub 2. Okay, so that's going to be that 223. A sub 1 is that 211 plus n minus 1 is just going to be 1 times d. So if we subtract this 211 to the other side to solve, we don't have to have that 1 times d. That's just going to give us that d is equal to 12. And that's what we're looking for. You could have done the same thing with a sub 3 or a sub 4. As long as you have the first value, so a sub 1, one of the other values, and its place in line, so whether it's the first, second, or third one in the sequence, then you can determine the difference. Example 2. Grace wants to deposit $5,000 in a certificate of deposit for a period of 2 years. She's comparing interest rates quoted by 3 local banks and 1 online bank. Write the interest rates in ascending order, okay, which is smallest to largest, because it's ascending. So which bank actually pays the highest interest for this year, or for this 2-year CD? So these ones we need to change into decimals if they are written as fractions. So I'm going to go ahead and do 1 times 4 is going to be 5 plus this 1 gives you 6 over 4%. And then if you type that into a calculator and you I just realized I literally just said that 4 times 1 is 5. Ignore me. 4 times 1 is 4 plus 1 is going to give you 5 over 4%. And then if you change that into a decimal, you get 1.25%. Same with this one. 8 times 1 gives you 8 plus 3 gives you 11 over 8 if you change this from a mixed fraction to an improper fraction. Okay, so it's going to be that 11 over 8%, which is going to be about 1.375% if you put it in a decimal. And these ones are already written as decimals. So we need to write them from small to largest. Looks like the smallest number is going to be this 1.22%. Then from there we would have this 1.25%, or this 1 1/4%. Okay. Then we'd have this 1.3% for this land savings bank. And then lastly, we'd have this 1.375 because it's a little larger than that, but that is the 1 3/8%. Okay. So the bank that has the highest interest would be the eSafe Bank, because that's the one at the end, because it's the highest number. Example number 3. Amy's savings account must have at least $500 in it, or he's going to be charged with a monthly fee, $4 fee. His balance was $716.23. Okay, so his original balance was $716.23, but he withdrew $225. Okay, so we're going to try and figure out how much he has after the withdrawal. So whenever you subtract that, you're going to get $491.23. But since he dropped under $500, he's going to be charged that $4 fee. So we can also go ahead and subtract that $4. So it's going to leave him at $487.23 for this month. Okay, so that's going to be his balance after withdrawal, because he took the withdrawal out still, but then since that dropped under $500, he was charged $4, so you have to take $4 more out of the account. Example number 4, Mitchell deposits $1,200 into an account, okay, that pays 1.5% simple interest. So this is one of the ones where we have this formula that we were looking at earlier. So again, this is going to make a lot more sense now that we're working on practice problems. So the 4 things you're going to be looking for are the interest, that's what I is, the principal or the initial balance, R is the interest rate and it has to be represented by a decimal, not a percent, and then T is the time in years. So Mitchell deposits $1,200, so that's going to be the principal because he deposited $1,200. This account pays 1.5% simple interest, so 1.5%, we take this decimal and we move it to the left 2 times. There's a blank here, so we're going to have a 0 there, 0.015. Okay, so that's going to be your R. And then it says you're leaving it in there for 3 years. So time is going to be 3 years. So how much interest do you get? Okay, so this I is going to be P, which is 1,200, times the rate, which is 0.015. Okay, and then time is 3 years. Okay, so this interest is going to be whatever, 1,200 times this number, you're going to get $54. So that's how much interest this account has accrued, but it's not asking you how much interest has he gotten. It's saying how much is in the account. So he deposited $1,200, and then the bank paid him this $54 in interest. So now that it's been applied, he would have $1,254 in his account. Okay, so some more simple interest ones. Again, we have I, P, R, and T. How much simple interest, okay, so we're just looking for the interest, does $2,000 earn? So you put $2,000 in at the beginning, 7 months. So again, I told you if it says months, you need to make a fraction of whatever number you got divided by 12. Okay? So the time is going to be 7 out of 12, so that's 7 out of 12 months of a year. And the interest rate is 2%, okay? But if we take the decimal point that's here, move it to the left 2, that will be 0.02. Okay? So again, we're looking for I. I is equal to P times R times T. So the principal we said was 2,000. The rate was 0.02, and then the time would be the 7 over 12. You can just type this into a calculator, okay? And then if you do type that into a calculator, first off, make sure you have parentheses around things, and make sure you put 7 divided by 12. You would get that you earned $23.33 in interest. So that's how much interest $2,000 would earn in 7 months at an interest rate of 2%. Another one. So we have the I, the P, the R, and the T. So the interest, the principal, the interest rate, and the time in years. So how much principal must be deposited, so you're looking for P in this one, in order to earn $1,000 in simple interest, so $1,000 is the interest, in 2 years, so time is 2, at a rate of 1.3%. So again, we need to move the decimal place over point over 2 places to make that into a decimal instead of a percent. So we end up with 0.013. And again, I is equal to PRT. Now you have an option here. I'm going to show you how to do it one way, and then I'm going to show you how to do it another way. So if we have I equals PRT, the first way to do it would be to solve for P first. So we're looking for P. It's being multiplied by R and T, so we can divide by R and T. Okay, so that would cancel those out, giving us that this P is equal to I divided by RT. And then you can just go ahead and put in the numbers. So I would be 1,000 divided by R is 0.013, and then the time is 2. Okay, and you can just type that into a calculator and get an answer of $38,461.54. Or you can start from the beginning and go ahead and solve, or put in the numbers. So I is 1,000. We're looking for P. R is this 0.013, and then time is still 2. Okay, and from here we can go ahead and multiply the 0.013 times 2, so you get 0.026, and then we still have this times P at the end, and it's still equal to 1,000. And then from there you would divide by the 0.026, and that would solve to give you P still, and that would still give you this answer of $38,461.54. So either way you want to do it, whether you want to solve for the variable and then plug in the answers or the numbers, or if you want to plug in the numbers or the values and then solve for the variable, you can do it either way. Either way, this is going to be your answer. Example number 7. Derek has a bank account. Okay, this is another one of those. We have the interest, the principal, the interest rate, and the time. Derek has a bank account that pays 2.1% simple interest. Okay, I'll go ahead and put that over. So it's 0.021. Okay, the balance is $910, so the principal is going to be $910. When will the account grow to 1,000? Okay, so we want the whole account to be 1,000. If they only have $910, what would they have to add to give you to 1,000? They would only need $90 more in interest. So the interest they need to get $90 in interest in order to hit 1,000. So we again can either go ahead and solve for T at the beginning, that's what I'm going to do, or you can go ahead and plug in the numbers. So since we're looking for T, we need to divide by this P and R. Okay, cancel them out on this side. It's going to give us that T is equal to this I divided by P times R. So we're looking for this T. I, we've got written here as $90 divided by P is the $910, and then R is the 0.021. Okay, type that into a calculator. You're going to get that T is about 4.709. Okay, and remember, that's going to be in years. So it's 4.7 years. So it's going to be 4.7 years. So we're going to have 4 years, and we have 0.709 years after that. Okay, but we're going to multiply that by 12 to see how many months. Okay, so 0.709 times 12, type that in a calculator, you're going to get about 8.5, so about 8.5 months, so about 4 years, and let's say 9 months. So again, the whole number, whenever you do solve for time, is going to be the number of years, and then you're going to take whatever's past the decimal point, and multiply it by 12 in order to see about how many extra months. And then example 8, Kira invests $5,000 in a simple interest account for 5 years. So we have invests $5,000, that's going to be the principal. Simple interest account for 5 years, T is going to be 5. What interest rate, so we're looking for the rate, must the account pay so that there's $6,000 at the end of these 5 years? So we went from $5,000 to $6,000. So we have an interest of $1,000 added. So again, we have I equals PRT. We need the R, so in order to get rid of those things, we're going to divide by P and T. So those cancel out. We still have these on this side. So we have that R is going to be equal to I divided by P times T. Okay, so the interest that we've gotten on the account at that point will have been $1,000. Principal was $5,000, and then the time was 5. So if you type that into a calculator, you're going to get 0.04. So if you show it as a decimal instead of a percentage, it'd be 0.04. But if you need to go back to a percentage, you're going to move the decimal point over 2 places. So that would be 4% interest. So again, for all of these problems, it's either going to be one of the arithmetic ones where you have the, where you have the a sub n is equal to a1 plus n minus 1 times d, or it's going to be one of these where you use I equals PRT. Okay, remember, if it tells you in months, you put whatever number as divided by 12 as the time. If you end up solving for time, the whole number is going to be how many years? Whatever's past the decimal times 12 is going to give you how many months. So if you guys need any extra help on this, let me know. Let me know if there's any questions or if there's any of these that you weren't sure about. Go ahead and do the practice problems now, and let me know if you have any issues. You guys have a great day. Bye.